Acist is a medical device company. We primarily design and develop injection systems for delivering contrast.
Acist has revenues of approximately $100 million. We have 220 employees worldwide.
Acist has over 2,500 systems installed worldwide. We've automated the process of injecting dye into the vascular system.
That allows physicians to visualize anatomies in order to do therapeutic solutions.
Since 1998, we've performed over 10 million procedures.
Our key customers are the physicians and clinical technicians that use our product on a day-in and day-out basis.
Where our efficiency really comes from is how do you get that new solution in front of that physician? How do you get it there quick? The FDM process allows us to develop machines and design that overall solution very quickly.
It's a world of difference between machining versus something that you can print in a day.
We use this technology for other than prototyping, but for production parts.
When we bought into the FDM technology, we never pigeonholed ourselves into a particular arena. We like to use it for everything. We look at it as a tool to give you some industrial design. We do it for functional testing. We use it for making fixtures. We're also looking at using it in some end-use parts and some products.
In one instance, we develop a system, a CVI injection system.
The original machine was really designed around delivering contrast. I guess as an afterthought, you always have to put this pressure transducer in.
The transducer, the sensor that's measuring the characteristics of the blood flow in the heart.
One of the things that physicians are doing is they're starting to add more transducers. As they add more transducers to get more lines or more signals, what we've seen is the arm just simply doesn't hold up. If we look at the FDM process, we can print concepts and make it a little longer, a little smaller, maybe it rotates left, right, or whatever. We were able to put several concepts in front of people and get information quickly. It's easy to engineer a beam and put something out there, but how it interfaces and somebody uses that's the difficult part, and you really need to be able to iterate and change quickly, and so the FDM process gave us flexibility overnight.
Without FDM, we probably wouldn't be able to come up with a solution that we came up with today. It's a complex solution, but simplified in terms of physician, and FDM helped us get there.
The CTA is a lower pressure injector. We're going through a product update, but we're really looking at producing maybe the first production run using the FDM process. It makes a great substrate for the process and for the parts. It also allows us to really do some design for manufacturing and eliminate a lot of pieces. You can reduce part count by putting complexity into one part. It also allowed us to develop the product and get a new updated version to our customers. It's pushing out our decision on the moldings. You don't want to invest in a new mold or new technology until you're quite sure that's what they want. And if you can design with FDM in mind, there's just so many benefits that you can have, but it has to become a mindset. What the FDM technology allows you to do is it really allows you to put a plastics manufacturing center inside of a lab, and it allows you to make any geometry out of any file, and you're never stuck with one design.
I think it facilitates the creative process.
It really has changed the whole industry significantly as far as how long it takes to get products to market.
It kind of changes the dynamic, and it really sort of upsets the traditional manufacturing world. And if you've got the right volume and the right product, FDM can solve a lot of problems.